So after now we know we should have a null vector. Therefore, we have an error E. If we have an error E, then think about this. Here, right now we have H partition matrix, and if we have S, H transpose, and C8E multiply H transpose, C can be removed, and suddenly you have an E multiply H transpose. Why? Because 0 plus that one. Or maybe you can think this one, and this one is 0. So finally you have this. Because you cannot guarantee E multiply H transpose, you still have a 0. But possibly you still have 0, right? So if you still have 0, then you see nothing. Why you see nothing? Because you feel everything is okay. Even you have an error E. So it's possible. But right now we assume if we want to have a 0 again, the chance is really low. So that's why we think we still have this one. And this one possibly can be observed. Can be observed, then it serves as a syndrome. Well, syndrome, what it means? First of all, I don't know, it is called a syndrome. This one. Something like this is the mental condition or disease condition. And that condition can be found, and then maybe you find some problem. And let me check Chinese character directly for local students. This one. Alright, why I would call this? Because this one allows us to have the observation. So it's true, this one serving as a syndrome. Well, so we have error multiply the transpose of a partition matrix. Then we can have the calculation for syndrome. Well, so up now, if we are given the previous value, so we have a G and we have H, up now, serving as a known information. Right? Known information. And right now, maybe we can have a test. How about input message using 1011? Sure, you can have this one. You can check it. See. Right? But now, if no error, how about syndrome? All zeros. However, we know it's we know we should have this message 1011001. This one should be the perfect one, but we try to have the errors. For example, try to alter the bit using this. Alright, so we change this one. It should be 0. 1011. Change it to 1001. Right? Only one bit change. And this time you should have a syndrome. Look at this. We just follow the previous calculation. It's S. And then this is H transpose. H transpose, that you know is P. And this is I, R by R. So we have this. If we have this, then you can have the multiplication. How to have the multiplication? Let me emphasize this again. Row and column vector. So of course this is first one, second one, and third one. right? So you have a 101. If you have a 101, can you find any specific pattern? 101, where we can find 101? Right? So that says if you have a 101, it's a single. And you can find, well, 1, 2, 3, the third vector. The third vector that says, oh, you can find what happens. One bit is flipped. Which bit is flipped? This one. 1, 2, 3. Oh, sorry. The third position, this one, the third position is flipped. So if you know this one, you can change it back to 1. And then that's done. Therefore, just have a single arrow. Since this syndrome indicates arrow position. How to find arrow position? Same as this one. So it should be the third position. The third position, then you can correct the third position. So of course we should change it to 1011, not 1001. That's it. So third position, so you can find it's the third position. That's all. All right. So this one, 1, 2, 3. So it's 1, 2, 3. The third position should be corrected. So this is a single. But sometimes sorry, it's not so simple. So we may have the combination of all flip bits and put them together. Then sometimes you cannot find it. Still 0. However, you know something wrong, but finally you cannot see anything wrong because you have a 0 back. This time it's the simple ones, of course. We then have a single bit error. And the single bit error, then we have the indication. Perhaps some of you may think about this. Is it possible to have any combination and so that we still can find any combination of bit flips? It's possible, but sometimes not really easy to find out all of the possible ones because maybe we don't have the single mapping. So it won't be easy to know if it's a mixture of the combination. Then you can reverse it. No, sometimes no, but this time this one can be reversed, so no problem. Well, I emphasize the part here. About the current discussion, we can use syndrome to reflect the error position. Think about this. If any question, you can let me know. So 1 to 2 minutes, think about this.
So it's certain if the error occurs, then the result is in the H transpose matrix.
For this one, a single one is possible.
So single error is definitely
Find one. Yeah, that's correct. That's possible. If we just have a single bit error. Single bit error is possible to find. Error occur for this row, or the other rows. It's possible. So that's why we have this one. You can find the position and you can correct it directly. However, if we have multiple errors, then it's a different story. And possibly you can try to have some possible patterns. It's possible.
So the 2, 3, 4 is error at the same time. It will be
0 possible. So that's why I know even we have 2 errors, but sometimes they can be cancelled. Yeah.
I think in this case, 2 errors will never cancel each other because you can see the.
Perhaps we can have the mixture of some of them, but you need to have some further processing. It's possible. Yeah, so I think that's true. You are right. But sometimes, maybe, for some cases, it can be cancelled. But sometimes, no. Maybe you have the mixture of the 2. However, you try to solve. Oh, the syndrome here can be any part of the mixture of them. If yes, then you know, well, identify second one, the fifth one, they should be corrected. It's possible. But it's a story beyond the current discussion. So that's why I just let it have single bit error, and we want continue further. Here we are showing a single bit error. And then Eugene, it's okay? Okay, right, Eugene? Right, and Christopher? Just assume a single bit error, so we can have this. So let me continue.